This is STAAR Review, Lesson 1, Classifying Numbers. Numbers may have classifications such as even and odd or positive and negative. You have learned how to classify even and odd numbers. Positive numbers, you really need to learn vocabulary as well. So I'm just going to highlight some vocab as we go. Positive numbers are greater than 0 and lie on the right of 0 on the number line. Negative numbers are numbers that are less than 0 and they lie to the left of 0 on the number line. We often see thermometers, sometimes in real life, and thermometers would be vertical and your positive numbers would be on top, your negative numbers would be on the bottom. So we have number lines in real life. You just need to start looking for them and knowing where the numbers go. Positive is always to the right or above 0. A set of real numbers includes rational numbers. Okay, so this is real numbers. They include rational numbers, integers, and whole numbers. Whole numbers are made up of 0 and the natural or counting numbers. The set of whole numbers can be represented as 0, 1, 2, 3, 4, 5, and so on. Sometimes we have problems remembering our whole numbers. And think of this. If you have a whole pizza and you share it with some friends and you eat the whole pizza, there are 0 slices. Okay? If we have natural or counting numbers, it's a different set of numbers, that would be 1, 2, 3, 4, 5. Okay? Because if you'll notice, it says made up of 0 and natural or counting numbers. Natural or counting numbers is 1, 2, 3, 4, 5. And I always tell people, if you're thinking about the natural or counting numbers, if I had my pins out here, I would naturally go 1, 2, 3, 4, 5. So naturally, you count starting with 1. But whole numbers, like I said, think of a whole pizza. When your friends eat the whole pizza, there are 0 slices left. So whole numbers are made up of 0 plus your natural and counting numbers. Integers include the set of whole numbers and their opposites. That's the key word right there, and their opposites. Integers we can put on a number line, but they are going to include all of your whole numbers, so 0, 1, 2, 3, 4, 5, and up, and their opposites, which would include -1, -2, -3, -4, and so on. That's as simple as integers get. When we get into the more complex numbers, you're going to have rational numbers. They are numbers that can be written as a fraction or as a ratio of 2 integers. The set of rational numbers includes terminating decimals, such as 5.56, and repeating decimals, such as 0.015, where the 15 will be repeating because that's what the line is over. That's your notation bar. This is because any decimal can be written as a fraction. For example, 5.56 can equal 139 over 25, and 0.015 repeating can be written as 1 over 66. Whole numbers and integers are also rational numbers because they can be written as a fraction with a denominator of 1. For example, negative 10 can also be written as negative 10 over 1. The Venn diagram shows a relationship among real numbers, rational numbers, integers, and whole numbers. The diagram shows that whole numbers are also integers, rational numbers, and real numbers. Integers are also rational numbers and real numbers. Rational numbers are also real numbers. So, it gets a little confusing at first, but all your whole numbers are right here in the middle. It makes the whole pizza. And we're going to start with 0, 1, 2, 3. Okay, sometimes it helps to make this so you can see it as you're working some problems. Your integers are the next circle. Well, integers can be whole numbers. It includes them. So integers are whole numbers and their opposites. So we have negative 2, negative 5, but we have 0 and 1 and 2 also. Those are your integers. So integers include whole numbers. Rational numbers will also include integers and whole numbers. So rational numbers will include negative 5, 0, and 5. But it can also include 1/2, 0.5, 0.63 repeating. And all of these numbers are real numbers. All of these numbers are real numbers. Now there's another section that you'll learn later, and those are irrational numbers. And they are usually on a box beside. Those rational numbers would be pi, because pi is 3.14 dot 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 dot. It goes on forever. We cannot put pi on a number line. So mainly remember your real numbers and rational numbers, integers and whole numbers. Now, negative 5 is not a whole number, because if you eat your pizza, you cannot have a negative 5 slices left. So negative 5, negative 2, negative 1, all your negatives and decimals and fractions do not go into whole numbers. Integers, it does, just negatives and positives. When you become rational, they can go on the number line, and that includes decimals and fractions and repeating decimals and terminating decimals and your whole numbers with your integers. And when you're doing your work, if you need to make your own up on the test, then I would suggest you do that, just so you don't forget where they belong. All right, well, let's start with number 1. Classify negative 11.5. Is it a whole number, an integer, a rational number, or a real number? Choose the most specific set. Okay, so can it be a whole number? So it's not a whole number. Well, yeah, it cannot be a whole number. Is it an integer? Could it fit inside our integer circle? No, because we're looking for the most specific set. And we're looking for rational numbers over here. Remember, we said these can be decimals and fractions, percents, whatever, in the rational number. So for your most specific set, it's going to be rational numbers. Number 2. Classify negative 100 by naming all of the sets to which it belongs. Now we're wanting to see all sets. Okay, all sets. Up here we were looking at specific sets. Now it's all sets. So we need to classify negative 100. Okay, remember if it's inside of the integer circle, it can be a whole number too. Integers can't go in holes, but the holes can be into integers. Integers and holes can be part of your rational numbers. But rational numbers cannot just jump in here to the middle. So, negative 100. First, you need to decide where it belongs. So, it's a real number, check. It's a rational and real number, check. Because remember, you can work your way in from the outside. So if a negative 100, it would really go right here in integers, can also be the rational and real. So integer, rational, real. Yes. So we need to X these out because it actually can be more than those. But so whole numbers, integer, rational, and real. It cannot be a whole number. That doesn't exist. It cannot be a whole number. You cannot have a negative 100 pieces of pizza. So for all the sets which it belongs to would be C. Number 3. The table shows the depths of 4 fish compared to sea level. Which fish has a depth that could be best classified as an integer? Okay, so again, think of your diagram. Think of what's allowed in your integer. Okay, that's what you're looking for. Which fish has a depth that would best be classified as an integer? Not a whole number, not a rational number, just an integer. And if you need to look on the front side, you can look on the front side at our notes. Fish 1 is a negative 11.5. Fish 2 is a negative 7 3/4. Fish 3 is a negative 16. Fish 4 is a negative 8.25. Okay, and this is the depth in the sea, so it's going down below sea level, so therefore they're all negatives. But if you'll look carefully, there's one that's a little bit different than the others that can only go into this section of integers. Okay, use the Venn diagram for questions 4 and 5. Which of the following numbers can be the variable m represent? So I want to know m. M is an integer. Which number could be placed there? 0, negative 21, 17, and 2/3. So which one best fits in the integer section that could not be in the whole numbers and could not be in the rational numbers? Something that is very specific to integers. Number 5, which of the following numbers can the variable n represent? So now you're wanting to look at n. And it needs to be something that can only fit in the rational numbers. Only fit in the rational numbers. A is negative 15/3. And really look at this because you have big man on top. That's improper. So we have to reduce and simplify this. It's improper, so we need to make it proper. 15 is larger than 3, so 3 can go into 15. So turn this into a negative 5 because 3 can go into 15 5 times. You have 14, you have a negative 22, and then you have a 0.3 repeating. So which one of those best describes a rational number that can only fit in the rational number circle? Number 6. The Fahrenheit scale, water boils at 212 degrees Fahrenheit. Classify this value as a whole number, an integer, a rational number, or a real number. Choose the most specific set. So again, which one does it mainly fall in? And I just kind of like to rewrite and get my numbers out of all the words. So we're looking for 212 degrees Fahrenheit. And we're looking for the most specific set. Is it a whole number, an integer, a rational number, a real number? Number 7. Texas is the second most populated state in the country with an estimated population of. We're going to classify this number by naming all sets to which it belongs. So now we're going to take this number and classify it all sets. All sets. So can it be a real number, a rational real number, an integer, a rational and real? Can it be a whole, integer, rational, or real number? You want to, what can it fit into the most? The table shows the sizes of some of the Forstner bits in Caleb's collection. Which drill bit has a size that would best be classified as a whole number? So I'm looking for something that can be classified best as a whole number. 7/8, 1 1/4, 2, or 2 1/2. And we want to pick the one that can only go into the whole number. Number 9, classify 10,459 as a whole number, an integer, a rational number, or a real number. Choose the most specific set. So again, you're taking the number and you're going to do the most specific set. Whole number, integer, rational number, or real number. What can it fit into first? Number 10. Maria dove to a depth of 12 feet below the surface of the water. This can be represented by the number -12. To which number does -12 not belong to? If I'm circling words, it's usually pretty important, and it would be great if you got in the habit of also doing that so you don't get tricked from their questions. And the depth, she dove into the water and it was 12 feet below. You know, you're going to have to end up writing these out yourself instead of them giving it to you. So just know 12 feet below is going down. And remember on the vertical number line I was talking about on the first page, your negatives are going to be below 0. But we're looking for something that does not belong. Okay, so it's going to belong in some other groups, but it cannot belong in this one. Can it not belong in a whole number, an integer, a rational, or real number? Number 11. Which of the following is not a true statement? Not true. A whole number whole numbers are integers. All whole numbers are integers. All rational numbers are integers. All integers are real numbers. All rational numbers are real numbers. So you're looking for what is not true. Number 12. The school auditorium holds 375 people. So far, 300 tickets have been sold to the school play. Classify the portion of the auditorium that has been sold out as a whole number, an integer, a rational number, or a real number. Choose the most specific set. Okay, so again, I'm going to box that, circle it, highlight it, do whatever you need it to do to remember what you're looking for. So we have 375 people that the auditorium can hold, and there's been 300 tickets that have been already sold. So you have 300 over 375 that have been sold. Which most specific set can this belong to? Of course, it needs to be reduced, but you can answer it without reducing it. Number 13. Classify 400 by naming all the sets to which it belongs. Okay, we haven't talked a lot about percents, but I have mentioned it before, and we're going to do it all sets to which it belongs. Back over here, okay, on rational numbers, it can be like 50%. You have 50% because 50% is 0.5, and it's also 1/2. So it can fit in the net rational numbers. Okay, I didn't put it on the chart earlier, but I did mention it. Okay, where were we? So which of the following is not a true statement? Okay, that's not where we were. Oh, we're on the back side. Sorry. So we're classifying 400 by naming all of the sets to which it belongs. Okay, number 14. Miguel climbed at a height of 25 feet above sea level. So if it's above sea level, it's going to be a positive 25. This can be represented by the number 25. Classify 25 by naming all the sets to which it belongs. All sets. Real, rational, real, integer, rational, real, whole, integer, rational, and real. Number 15. Martin is 3 years younger than his sister Abby. Abby is 15 years old. Classify Martin's age by naming all the sets to which it belongs. All sets. So if he's 3 years younger than his sister, 15 minus 3. So classify his age in all the sets to which it could belong. Real, rational, real, integer, rational, real, whole, integer, rational, real. And number 16, what is the smallest number that belongs to the sets of whole numbers, integers, rational, real, and real numbers? Record your answer in use the correct place value. A lot of kids are going to miss questions on their STAAR test because they do not know how to bubble in their answers. Okay, so we're going to record it using place value. What is the smallest number that belongs to the set of whole numbers? Okay, integers, rational numbers, and real numbers. But we're looking at whole numbers because whole numbers can fit into every other category. But what's the smallest number that belongs to the whole number family? Remember I said about a pizza, if you get a pizza and you eat all of it, there are 0 pieces left. So make sure this is your decimal. All numbers go in front of decimal as far as whole numbers. Okay, whole numbers go in front of your decimal. Okay, if you want, I'm going to verbally tell you what the answers were. You can go back and check yourself. If you have any questions, you can ask them on Google Classroom. Number 1 is C. Number 2 is C. Number 3 is C. Number 4 is B. 5, D as in dog. 6, A as in apple. 7, D as in dog. 8, C as in cat. 9, A as in apple. 10, A as in apple. 11, B as boy. 12, C as cat. 13, D as dog. 14, D as dog. 15, D as dog. And 16 is 0.